All right, so here's a problem that I want to solve for you. Most students, whenever they hear the word collisions, their mind immediately goes to cars, but that's not the case. We have collisions all the time in our lives. Almost every couple of minutes, we're having some sort of, if you will, collision. Sometimes, collisions are actually catching, throwing, all sorts of things. Anytime two objects either are separate and come together, or are separate, come together and go back apart, they bounce off of each other, or together and then separate, that's still a collision. So here's a common sports one, if you will. I have an athlete, basketball player, training using a medicine ball. Now the medicine ball is much heavier than a normal ball because it's filled with sand or some other substance besides just air. And I give you the mass of the basketball player. And then she's not a basketball player. And then the mass of the medicine ball that they're tossing back and forth, that our coach and her are tossing back and forth. And then I want to know, I give you the velocity, and I want to know the resulting velocity of the player after she catches it. So the first thing you have to do in any momentum problem is you need to identify which type of collision this is. So first off, recognize this is a momentum problem. I have two things that are separated, and then there's a collision that occurs. The two things come together there. We're not talking about work or compression. There is no mention of delta X in here. Note that. So this isn't going to be a work energy theorem problem. This is a momentum problem. Next step is to actually identify which type. Is it elastic, inelastic, or explosion? The way you do that is you think, how are the objects starting out? The answer is they're starting out separated, right? And then you ask, all right, so now afterwards at the final, where are the objects? Well, the girl catches it. So they come together. They start out separated and then they come together. That would be a great inelastic. So I have M1 VI plus M2 VI equals final velocity times M1 plus M2. And this should somewhat make logical sense to you because the two things are separated in the equation on the initial, and then they are joined in the final because her and the ball, she catches the ball, right? So both of them are going to move backwards at the same sort of velocity. If you ever played with the medicine ball, it's going to knock you back just slightly. All right, so let's call object 1 the basketball player. So I have 69 kilograms that I substitute in here. And then VI initially is 0. And I'm going to solve this through with numbers as opposed to letters to try to highlight some of the things, make it a little bit easier for you to understand. But the initial velocity of the basketball player is 0. She's just standing there, stationary, right? All right, M2 is the velocity of the medicine ball, so that's 5 kilograms, and it looks like 5.00 there. And the velocity, 6.85 meters per second, equals final velocity is what I'm looking for, times the two masses add together, 69 plus 5.00. This would be a good time to say, be very careful of positives and negatives. Now, in this problem, everything is going the exact same direction, right? The velocity is going this way, and I'm going to call that way positive, right? And I don't have to worry about any initial velocity over here for the other person that might be going the opposite way, and I'd have to call it negative. Just be very careful with your velocities, because if one object is going left and you call that positive, and another object is going right, you must call that negative. Opposite directions, negative. Which, by the way, is going to mean, I should have mentioned this in my last video, that momentum is a vector, because velocity there is a vector, right, giving direction, and any vector times a scalar, mass is a scalar, right, it gives you a vector there. So momentum, vector. All right, so now I've got everything written out. I just need to solve for my final velocity. 0 times anything is 0, so that completely goes away. So in other words, the momentum of the ball, right, which is 34.25 kilogram meters per second, is going to equal the momentum of the girl and the ball together, which is VF times 74 kilograms, right? And so now we just divide both sides by 74, and we come out with our answer, VF, and let's actually make that look a little bit nicer here. VF equals about 0.4628. And let's look at sig figs. I have 3 sig figs up here, 3 sig figs here, but 2 sig figs in the mass of the basketball player, and the mass of the basketball player is used in this problem, so I have to go with 2 sig figs. 0.46 meters per second would be my answer. So the girl's going to get, if you will, knocked backwards, which I'm calling positive. It's going to get knocked backwards at a rate of 0.46 meters per second.